All right. So we have talked about series circuits. We've talked about parallel circuits. Okay? But when we think of regular, everyday working with electricity, working with circuits, there's two things we basically think of. Turning things on and turning things off, which is logical. Okay? But the interaction that most people at some point in their lives have to deal with is light bulbs. Okay? At some point in your life, a light bulb has gone off. In a lamp, in a ceiling fan, right? And you've had to change it, yes? But can you just pick any light bulb and stick it in? No, right? It has to be the right size, and especially it has to be the right something else. There's always a number associated with the light bulb. What's that number? Watts, right? 60-watt bulb, 120-watt bulb, right? A 30-watt bulb, and they're different brightnesses and all those things, right? So when we're talking about electricity, we've always dealt with this concept of watts. And you never really thought anything about it, right? You go to the store, right? Your mom maybe asks you, your dad asks you, go get light bulbs because we're out. You go to the store, you go, I need a 60-watt bulb, and they give it to you, right? So we've seen this word, watt, right? With light bulbs. My entire life. Never really thought anything about it. Then you took physics, and this crazy teacher that you have standing in front of you taught you that word too. But he didn't teach you that word when he was talking about light bulbs. When did we learn this word watt? When we were talking about what? Power. Okay? Earlier in the year, when we were talking about power, we learned about this word, right? And we talked about it in that whole unit where we were talking about energy and work and all those things, right? And you lift something up and you give it a certain amount of energy. And if you time how long it takes you to lift that up, then that gives you the power, right? Yes? And we ended up with a formula that looked like this. Everybody remember that formula? Right? P stands for power. What does the W stand for? Work. What does the T stand for? Time. So power equals work over time. Cool, right? That works really, really well. Okay, we know that the unit for work is what? Joules. We know that the unit for time is seconds, so we ended up with a unit of joules per second, yes? But instead of saying joules per second, we just call it a what? Right? This is nothing new. This is old school stuff, right? We've done this. Now, what the heck does this have to do? Well, when we've been talking about electricity, we've seen on multiple times that there's a similarity between that unit that we originally did with energy and all this stuff we did with electricity, right? We talked about gravitational potential energy, lifting an object up that has mass against the gravitational field and giving it a certain amount of potential gravitational potential energy, yes? Likewise, last week or 2 weeks ago, whenever it was, we said you can take an object that has a charge, lift it against an electrical field, and give it electrical potential energy, or what's the shorter word? Instead of electrical potential energy, voltage, right? You had that similarity, right? We've got energy, we've got particles that are moving, very similar to stuff that we talked about with kinetic and potential and all those other things, right? We said energy has to be conserved. So we see tons of similarities between that topic and the topic that we're talking about now. Well, as it turns out, this is also similar. We can have what we call electrical power. Okay? Electrical power, this is what your parents have been yelling at you for years about, right? When you leave a room, what do they always tell you to do? Shut off the light, turn off the fan. What do you think I'm made out of?
Money.
Money. You've all heard this many times, yes?
Too many.
Too many times. In my case, it was usually followed up by a flying slipper to the back of the head. Colombian mother, you know these are the ways these work. I love my mom, but she's deadly with a slipper. Okay, she's like a Colombian ninja. Okay, but you've heard this over and over again. How do you think I made our money? Why? Well, because that light bulb that we were talking about at the beginning, that 60-watt light bulb, it's 60 watts. What does that mean? That means that it pulls 60 joules every second. And ultimately, your parents get charged for that. You get an electrical bill and they yell at you and this, that, whatever. Right? So it's no different when we're talking about electricity versus when we're talking about lifting a heavy weight over your head. Both of them have to do with power. Yes? Now, if we were given a circuit and we said that you use this many joules in this amount of time, it'd be super easy to do, right? But come on, it's physics. Is it ever that easy? No. When we're talking about circuits, we're usually not given work and time. Maybe you'd be lucky and it will be. It's not going to happen very often. Typically, when we're talking about physics, we're given 3 different measurements that we've been talking about for the last couple of days that you calculated in your homework yesterday. What are those 3 measurements? Give me one. Voltage, current, and resistance, right? Typically, we're given 2 of those, figure out the 3rd one, right? You have this much current going through a resistor, that's this much, figure out what the voltage drop is. Or some combination of the 2, right? Well, it's no different with electrical power. When we're talking about electrical power, quite often we're going to be given either the voltage or current or resistance and have to figure out how much power do we use. Does that make sense? The question is, how the heck do we put voltage, current, or resistance into that? Right? Because that's going to be weird. How do we do it? Well, as it turns out, I'm going to give you the first formula and we're going to figure out how it works. The first way that we can use voltage, current, or resistance is that let's just say we had just voltage and current, V and the I. As it turns out, the amount of electrical power is equal to the voltage times the current. That's the formula. Now in your brain, you're going, huh? How'd you get from W over T to V times I? That doesn't make any sense. We need watts. We need joules per second. That doesn't work. Well, let's look. We had a formula for voltage. We had a formula to figure out voltage. What's our formula to figure out voltage? It's in your reference table. It's not cheating to look. What is the formula that we use to figure out voltage? What is it? W over Q. So W over Q, we can just substitute that for V, yes? Is everybody understand it? And we have a formula for current. What's our formula for current? Q over T. If we were to multiply these 2 out, what would happen? The Q's, the charges, cancel each other out. What are you left with? Which is? Power. So do you see how it works? Okay, so if you're given voltage, so if I tell you there's a 12-volt drop, like we did in the homework yesterday, and half an amp going through an object. You have a 12 volts, and 0.5 amps. How much power? 6 volts. 6 watts. Make sense? Super easy math. The math in electricity isn't hard. But what do you have to do? You have to make sure you use A, starts with a K, ends with an E. There you go. P. P's are going to be really important in these questions. You have to make sure you're using them. Everybody understand? But we all know how physics is. Do you think every single time we do a problem, you're going to get voltage and current?
No.
No. What happens? What's another possible combination you could get? Resistance and current. So let's say we got resistance and current. So who's missing out of this formula? If we have resistance and current, who's missing? Voltage. So voltage is missing. What formula connects voltage, current, resistance? Aggie. R equals V over I. Who's that named after? The guy who meditates? Ohm. Right? Now, we want V. We want to replace V, right? In this formula. So somehow we have to rearrange Ohm's law to solve for V. If we rearrange Ohm's law to solve for V, how would we rearrange it?
Multiply current on both sides.
Multiply current on both sides, so you get V equals.
Or RI.
Doesn't make a difference. The order doesn't make a difference. IR or I. How do you want it? Cool? Yes? What does that mean? That means anywhere in this formula that we see a V, we can replace it with I times R. Yes? So what do we get? So if we replace this one right here, this V that we see right here with that, we would get I times R times another I. Yes? Yes? That's messy. Let's clean that up a little bit. How can we clean that up a little bit?
I squared.
I squared times R. R. So we can get rid of, let's clean this up. If I can get rid of this too. And we can make it I squared times R. Would work the same exact way. Does that make sense?
Yeah.
Yeah? Okay, cool. So we did V and I, and we did I and R. There's still one more possible combination.
R and V.
R and V. Okay? Let's go back to the original formula we had. V times I, yes? Okay, once again, what formula connects all three values to each other? R is equal to V over I, Ohm's law. So now we want to get rid of, we said we're going to do V and R, yes? So who do we have to get rid of? What letter? I. So we have to isolate I, solve for I. If we were going to solve for I in Ohm's law, right? How would we rearrange it? What would we get? R over V? V over R. Let's see. I is in the bottom, right? Do we ever want our value in the bottom of the denominator? We want to get it out, right? How do we get it out? I didn't say anything back. How do we get it out? Multiply by I on both sides. What the? It's possessed. Okay, I don't know why it just moved, but okay. There we go. The board has a mind of its own. We're going to multiply both sides by I. So we're getting I times R equals V. That's not what we wanted, but we got the I out of the denominator. Now what do we do?
Divide R on both sides.
Divide R on both sides. By you get I equals V over R. Cool? Yes? So now, in this V times I formula, we can replace the I with V over R, yes? So we end up, once again, with V, and then in parentheses, V over R. That's messy. How do we replace that?
V squared over R.
V squared over R. Does that make sense? Now, regardless of what information you're given in the question, you now have a formula that you can use to solve for the power. Does that make sense? So all of these formulas, we'll rewrite them. P equals work over time. If they give you working time, boom, use that one. If they give you voltage and current, you use that one. If they give you current and resistance, you use that one. And if they give you voltage and resistance, you can use that one. All of these formulas will give you the same result. They all equal P. Now, it looks like a whole bunch of formulas, but are you going to use all of them at the same time?
No.
No, you're just going to use the one that fits the situation that you're in. Does that make sense? Okay. So what's going to be important for these questions is that you start off each question by making a key. You see how critically important the key is. Because once you make the key and you list for yourself the values that you have, then you can figure out which formula applies to the situation. Okay? Technically, yes. Can you do this just by looking at the question and thinking about it in your head? Yeah, but some people work like that, and some people need to write it down. Write it down. It helps. It helps to see stuff in front of you so you can figure it out. Yes? Now, what's weird is that the way we talk about this, we talk about power first. And the last time, we didn't talk about power first. We talked about work. And then we said work over time gives you power, yes? We talked about what is work and force times distance. Remember all that stuff that we did originally? Now we just jump straight into power. We kind of ignored electrical work. Or electrical work doesn't sound really, really good. That doesn't sound clean and crisp. This word work. In physics, it has a synonym. It has another concept that shares the exact same unit. But we don't call that work. What do we call that other concept that has the same unit as work? What's that concept called? What's the units for work? Let's start with that. Joules. So what else has a unit of joules?
Energy.
Heat, which is a form of energy, like we said. Okay? So work and energy are synonyms for each other in physics, yes? Sort of, kind of, yes? Yes, ma'am. Go ahead. Okay, cool. So we were talking about electrical power, so we can also talk about electrical energy. How much energy is used, yes? So we're going to talk about electrical energy. Okay. So electrical energy will work, right? Well, how do we figure that out? Well, we have a formula that already has it in there. We already talked about a formula that has work in it. What formula did we talk about that already had work in it? Power, right? Power equals work over time. Now, if I wanted to solve for work in this equation, how would I rearrange the equation?
Multiply time on both sides.
Multiply time on both sides. So I would get work equals,
Power times time.
which is cool, right? Let's say you did a question like we said before, right? 12 volts, half an amp, how much power do you have? Right? You figure out 6, and then I ask you, well, how much energy do you use in that time frame? Right? 2 seconds, 3 seconds, 4 seconds. You just take the answer you got, multiply by the time, boom, simple. Yay, answer. Cool. But is it always going to be that easy? What if I told you you have 12 volts, 0.5 amps, running for 3 minutes? How much energy do you use? Well, let's see. What's power equal to? Work over time. What else is it equal to that we just figured out? That's the units. What's another formula that we can substitute for P? P is equal to W over T. What else is it equal to?
VI.
Yeah, so I can substitute in V times I, but what do I have to include? Don't know what's going on with the board. It's being a pain in the backside. So I could use V times I times T, and that would give me work, electrical energy. Yes? Or, what else?
I squared R times R.
That would work too. Or,
B squared divided by R.
once again, you've got to change. You could use any particular one of these to solve for electrical energy. The key is making a
P.
key. Okay? Every electrical question that you did, the homework that you guys did yesterday with parallel circuits, what did they effectively do? They gave you the key and just asked you to fill it out, right? They were all listed out for you. Okay? But when you're doing a test, when you're doing anything, you're not going to be given the key. So you need to make sure that you're making that key and filling it out as you go along. Okay? If you do that, you're going to get the questions right. Okay? Better to get those questions right. Better to get a question. Maybe you run out of time and you miss one or two multiple choices. Get all the short answers right, the key and all those points. Than to rush through everything and make stupid mistakes, silly mistakes. Okay? When you're doing these questions, have a piece of paper and just jot down a quick key. It takes what, 5-10 seconds to write down a key? Just to write down what you know? If you had the paper in front of you, I'd tell you to write on the paper, but obviously you can't do that because you're taking the test. But it helps to figure things out. It helps to write things down. Does that make sense? So in your homework tonight, ladies and gentlemen, okay, which I'll post in a second, okay, you guys are going to use this formula. You're also going to use the parallel circuit stuff. You're also going to use the series circuit. It's going to be a combination of all the things you've been doing over the past couple of days, so you kind of get a good view of kind of what like your test is going to look like. Okay, so this is the last thing that we're going to talk about with regards to circuits. Tomorrow we're going to talk about magnets and magnetism, and then Thursday our goal is to kind of just do practice. We're going to do practice all day Thursday, and then your test is going to be on Friday. How does that sound? Good? Okay? So, if you have your review book, you can get started right now at page 129 to 131. If you don't have it, I will post it on your Google Classroom, and you can just do those digital sheets there. Cool? There's about 5 minutes left, so get cranking on your homework now. And we are done with that.
Is it
Yes.
every